Alright, section 3.4, we're going to start solving multi-step equations. The process is again the same thing for solving multi-step equations as it is for inequalities. I do have a couple reminders though. I think it's sometimes nice to rewrite things more than once. It does help us to remember them. So the first thing is follow the same steps as we did when solving equations. Only difference is to remember to change the inequality symbol when multiplying or dividing by a negative number. So when you have to multiply both sides or divide both sides by a negative number, that's when you need to change the inequality symbol. Looks like there needs to be an E in there. Next, it is possible to change the symbol more than once when solving a problem. So if you're working on the problem and you've noticed you changed it 2, 3, maybe even 4 times, that's okay. It can happen depending on the problem. So a quick recall of the steps that we need to take to solve a multi-step inequality problem. First thing that we need to do is distribute. That does not change. Second, we're still combining like terms. Third step, we're going to add or subtract. And then finally, fourth step is multiply or divide. So let's look at some examples. So what are the solutions of, and our first one is 2 times the parenthesis t minus 1 plus 3t is less than 2. So first, step number 1, we're going to distribute. So this looks like, there we go, 2t minus 2 plus 3t is less than 2. Now we can combine like terms, which is a positive 2t and a positive 3t, which give us 5t. Bring down the minus 2, keep that subtraction sign that's in front of the 2, and then is less than 2. Now we're ready to add or subtract, so we can add 2 to both sides. When we do that, we get 5t is less than 4. And then finally, we can divide both sides by 5. And we get t is less than 4/5. Now we're ready to graph our answer. So I'm going to go 0, 1, and negative 1. 4/5 is going to fall in between 0 and 1. I do need an open circle on 4/5. You have to approximate, and then our line is going to the left. Let's look at our second example. 4n plus 2 is less than 7n minus 13. So we don't have parentheses, so we can't distribute, but we can combine like terms, and we have variables on both sides. So that's when we're going to subtract 4n from both sides. Then we have 2 is less than 3n minus 13. Now we can add 13 to both sides. We have 15 is less than 3n. Finally, divide both sides by 3. So I have 5 is less than n. But again, we're going to remember to write our variable on the left-hand side. So switching everything around, n is greater than 5. And the last piece is graphing our solution on a number line. Reminder, we need at least 3 numbers. We want an open circle on 5, and it is going to the right. 2 more inequalities for us, and then a word problem. So 14 minus 6n is less than or equal to 2 times the parentheses 7 minus 3n. Now when we're solving inequalities, we can have a situation of a no solution or all real numbers that work, just like when we had equations. So for this one, what we want to do is distribute first. So I have 14 minus 6n is less than or equal to 14 minus 6n. And right away, you may notice that, hey, both sides of this inequality are the same. We can continue to solve if we wanted to. Add 6n to both sides. So we have 14 is less than or equal to 14. Is this a true statement? Yes, it is. So what happens is this is all real numbers. Maybe. These type of problems we don't need to graph on a number line, just looking for the answer, all real numbers. Alright, 4p plus 3 is greater than np plus 6 minus 5p. So we'll start by combining like terms. So I'm going to keep my 4p plus 3 is greater than, I'm going to combine 9p and the negative 5p, which is a 4p plus 6. I can subtract 3 from both sides. And if you were to go about this in a different order, that's okay. So I have 4p is greater than 4p plus 3. And then subtract 4p from both sides. Notice when I do that, my variable actually cancels. So I have 3, my greater than symbol. 4p minus 4p is 0p, which is just 0. So now ask yourself, looking at this inequality statement, is this true or false? Is 0 greater than 3? That is a false statement. So what happens is there is a no solution. Doesn't matter what number we put into this inequality, it's not going to make it true. Okay. So those are the 4 examples that I have. So no solution, all real solutions, and then 2 examples if you're solving and you get a number for an answer. Let's look at a word problem though. So you want to fence in a rose bed that is adjacent to a deck. The length of your deck is 14 feet. You have at most 44 feet of fence. What are the possible widths of the rose bed? Alright, so sometimes when we're working on word problems, it's helpful to draw a picture. And so for this, I do want to draw a picture. So you're building a fence that is adjacent to a deck. Right, so if it is adjacent to a deck, I'm going to draw a picture here. Here's my deck. It's beautiful. And then here are my roses. We're trying to fence this in. The deck is going to serve as one side of our rose bed, and so when we're putting fencing around, we only have to worry about fencing for 3 sides. If we're looking at this, if this right here for our deck is 14 feet, then over here, whatever length this is, most likely it's going to be 14 feet. Okay? So knowing the length of our deck will help us. And then we have 2 widths. So this distance going across here is going to be a width, and then over here. So if we have 44 feet, we're going to be looking at the perimeter to be making our fence. So what we have right now is we have 44 feet of fence, and that is the most fence that we can have. So I put the greater than or equal to because we can use all of the 44 feet. 14 feet of that is going to be used for one of the sides. The side opposite of that is the deck. And then we have plus 2 widths. So I'm going to put 2, oops, there we go. I'm going to put 2W to represent our 2 widths that we need fencing for. So there's our inequality. Now we can solve. We're going to subtract 14 from both sides. When we do so, we get 30 is greater than or equal to 2W. Now we are ready to divide both sides by 2. I have a W of greater than or equal to 15. And if I'm going to rewrite this, I have W is less than or equal to 15. So this means that the width of our raised bed can be 15 feet or less. So we need to write our answer using our words since it is a word problem. So our answer would be the width of the rose bed must be 15 feet or less. And that is how you would work through a word problem. Use a couple different strategies to get through those if you're not understanding.